Welcome back to this Python tutorial series on constructing a recursive descent parsing algorithm for a calculator. In today's video, we're going to be introducing parentheses and negation to our calculator language. So to begin with, and typically in calculators, negation is simply, let's say, -4, or we could say negative parentheses 4. Well, as we can see here, we are already using the negative sign, the subtraction sign as minus. And this can cause some problems in our grammar if we actually include that as the negation sign. So in this example, I'm going to include tilde as the negation sign. So if we want to say -4, we say tilde4, and this simply means to negate. And we have different kinds of values that we want to negate. So for example, let's say we want to negate a number, -4, or we want to negate parentheses of an expression. So let's say 3 times 5. We want to negate the entire expression. So we have to make negation a level of precedence that's that's lower than the operands. And we get away with this by introducing this new grammar. And this grammar also is responsible for parentheses. So we have many new productions, many new non-terminals. We also have a few new terminals as well. So L-par refers to a left parentheses, and our R-par refers to the right parentheses. And the negate refers to the tilde symbol. So let's look at an example of the derivation of the negation of 3 plus 5 times 7. So in our new grammar, start is a statement where statement is a term T1. So statement is a term T1. Term is a factor T2. So factor T2, T1. And factor is a negate and a final. And so the first symbol we see is a final, therefore we derive it as negate. And then we have our final. And then final is a number or an L-par. Our next token is an L-par. So we derive an L-par, then we derive a statement, which allows us to go back up to the very top. So now we're at the top again. And the statement is a term T1, and the term is a factor, and a factor is a final, and in this stance, our final is a number. And then we derive 3 for the number. So then we have our trail endings of T2 from the term, and T2 derives into epsilon, and that's what these E means. I forgot to say that in the last video, but in our derivation tree, the E stands for an epsilon transition. So here we have it. So T2 derives to E, and then T1 follows through, and it decomposes into operand 1 term and T1 again. Where operand 1 is the plus, term is now a factor T2 again, factor is a final is a number is 5. The T2 derives into epsilon, the T1 derives into epsilon as well. Then we consume the R-par as the right parentheses. The T2 derives into epsilon, and then the T1 derives, the T2 does not derive into epsilon, the T2 derives into operand 2 factor T2. Operand 2 is multiplication, factor is a final is a number is a 7. T2 then derives into epsilon, and then T1 derives into epsilon. So here we have our linear derivation, and to see a full derivation tree, here we have the following. So as we stated before, start derives in the statement. Statement is a product of 2 things, term and T1. And a term is a factor is a negation and of a final. So here we have a full tree. It works from left to right, and we circle around here. So we have our negation, our left parentheses, our 3, our epsilon transition, our plus, our 5, our epsilon transition again, our right parentheses, our multiplication, our 7, transition, and transition. So now, as we can see here, this grammar is completely different than the previous one, except for a few familiar terms, such as term, factor, operand 1, operand 2, and T1 and T2. So now we're going to have to almost redo our grammar, But to begin with, let's go back to our scanner because we're introducing three new terminals. And so we're introducing a parentheses. So we're going to make a new token. We're going to call lpar for left parentheses. We're going to pass in the left parentheses value. Tokens.append. We're going to copy and paste this for the right parentheses. And then our last new token we need to introduce is the negation, which is going to be the tilde sign. And we are going to call this, let me see, what did I call it here previously in my examples? Okay, here we call it negate. So now, since we finished up updating our scanner, let's go back down to the bottom. We're going to take this new grammar with us as a reference point. So now start is a statement. So I'm going to define statement. I'm going to pass in our iterator to it. And we're actually going to just copy and paste this here as so. So we're going to get our iterator. We're going to get our value from statement. And we're going to say if our value is none. If it is none, that means some kind of error occurs, so we're just going to return none. If it's not, we need to check to see if we reach the end of the list. So here we're going to take this, we're going to place it into start. Did we reach the end of the list as the last $sign token? If we did, then we return the value. If not, then some kind of error occurred. So now here we're in our statement, and our statement is a term T1. So we check to see what is term. A term is a factor, and a factor is a final or a negate. And a final is a number or an lpar. So now we have three different options in this peak statement. It could either be a negate symbol, it could either be a number, or it can be an lpar. So now we need to update this to apply to the left parentheses and the negate symbol. So if these occur, what we're going to do is we're going to pass on to term. So we're going to get 10 from term, and we're going to get value from that. And we are going to return this actually. So expecting number, negation, or left parenthesis. So now we have start and statement updated. Let us continue on to term. So term is now a factor T2, where a factor is a final, where a final is a number or an lpar, or a factor is a negate. So this is going to be either a number, a negate, or an lpar. So I'm just going to take this, copy and paste. So let's say if it's a number, or if it's any of these, we're going to not just consume it, we're going to pass it on to factor. Oh, excuse me, we're not going to pass it on, we're going to call factor, and we're going to store that return value inside a token. And we're going to say if token is none, some kind of error must have occurred, and we're going to return none. Else, we're going to return T2, which is exactly what we have. And we're going to have another error statement here. So if a number, negation, or a left parentheses does not occur, then some kind of error occurred, and this usually only happens in an empty input. On the first run at least, not on the second call. So now we have term, statement, and start updated. Let's now go to T1 and T2. So T1 is an operand 1 term T1. Alright, so we have our operand 1 here. And then we consume the next symbol. If it's a number, we pass it on to term. So T1 is looking good. Let's go on to T2. So T1 is actually the same as the last episode, except now T2, instead of, originally this was number here, but now it is factor. So we need to check to see what a factor is. A factor is a final, which is a number, LPAR, or negate. So this is either going to be a number, a negate, or a left parentheses. So I'm going to go back down here, copy and paste this expression. So here we all have it, except this time instead of consuming, we're going to get the value from, we're going to call it next, of factor, and we're going to pass in the value of factor into this. And they're going to return the T1 value. So let's go back to this example derivation tree. So here we have T2 as an example. We're getting the previous value, as we can see, the previous value is the value returned from this factor. It's being passed on to T2. And so now we have T2 here, and we're going to see, is it the next symbol an operand 2? If it is, consume it and store it in the operand. This example would be the multiplication symbol. And then next we need to get the value from factor. So factor can also be, as we stated before, a negation, left parentheses, or a number, so we check for that. And if it is, then we get the next value from factor, and then we actually perform the evaluation from this previous value passed on times the value returned from here, and then we pass that value on to the next T2. So here we're going to call this T2 here below, and I think that actually might have been a problem in our last video. I probably forgot to change that to T1. Excuse me, I forgot to change this T1 to T2 in our last video. So now T2 is completely finished, and so all we have left to do is implement factor and final, and we're going to implement those productions and functions in the next video. So stay tuned.